It's time to export the knowledge. In this video, we're going to be talking about area of shapes. So let's start with the bare basics. I have a rectangle. Its lengths are 3 and 4. So the area of this shape is going to be width times length, or length times width. It doesn't matter. Area equals 4 times 3, which is 12. We're done for a rectangle. For a square, let's say that this is 3. It's going to be 3 times 3, or you can say that it's width squared, and that'll be the area. So in this case, it's 3 squared, so it's going to be 9. And that's our area for a square. Now, let's move on to something a little bit harder, a triangle. So let's say that this is, its height is 7 and its base is 4. All we have to do to work out what this equation is, it's half base times height, or base height over 2. They're all the same thing. They will give you the area. So in this case, our height is 7, our base is 4, so I'm going to halve the base, so it's 2. 2 times 7, 14. That's our area. Now let's say we don't know what the heights are, so 3, 4, and 5. I don't know what the height is. I can't assume anything with this triangle. If you know what this triangle is, you probably realize, oh, hold on, this is a right angle triangle. I actually do know the height. But let's assume that we don't know that. Let's just assume that we don't know that, so we can use this new equation. So this is Heron's formula. So let's say this is A, this is B, and this is C. So all we have to do is plug it into this thing. So I'll work. The S here is the semi-perimeter. The semi-perimeter is just the perimeter divided by 2. So 4 plus 3, 7 plus 5, 12. 12 over 2, semi-perimeter is equal to 6. So S is equal to 6. Which is just A plus B plus C over 2. Right? There's the semi-perimeter. So now I just have to plug it in here. So 6 lots of 6 minus, and our A value is 4 in this case. 6 minus, and then B is 5. And then 6 minus and 3. So this will become 3, this will become 1, that'll become 2. 2 times 3, that's going to become 6. 6 times 6, 36 square root. 36 is going to give you 6. And that's our area here. Now, remember how I said that this is a right angle triangle? Well, we can use that to prove that this is right. So let's say our height is 4 and our base is 3. 4 halved 2 times 3 equals 6. They give you the same result. Okay, let's move on to a parallelogram. It's a terrible parallelogram, but it's the best that you're going to get. So this is 10, this is 2, let's just say. So our base is 10. So here's our parallelogram. Let's say the base is 10, and we'll say that the height of this parallelogram is 2. So the area of this parallelogram is going to be base times height. So our base is 10, our height is 2, so it's going to be 20, and that's our area. Okay, so let's move on to a trapezium, or trapezoid for you Americans. We have A and B. We know that's those two, and we know the height. That's all we need, so it's half a plus b times height, and that's the area. Now, might be thinking, why is that? Well, that's because this is two triangles if you think about it. We have a base, we have a height, and they share the same height, but different bases. And it's just two triangles smacked together. That's how this formula is made. So let's do an example. Let's say a is equal to 3 and this is equal to 6, and let's say the height is 2. So 3 plus 6 is going to be 9, times 2 is 18, and then times a half, height is equal to 2. So a plus b, that's going to be 9. So, and our height is 2. The half and the 2 cancel out, so we're left with 9. And that's our area for this trapezium. What about a circle, you may ask? It's very simple. Here's our radius. It's pi times the radius squared, and that's the area of a circle. So let's say our radius is 1. R is equal to 1. So pi times 1 squared equals area. 1 squared is 1. 1 times pi is pi. So the area is going to be pi. Easy. What about an ellipse or an oval? For this we have B and A. So this is the minor axis, or the shortest length from the middle. And this is our major axis, or the longest length from the middle. So all we have to do is say pi times A, B. So let's say A is equal to 2 and B is equal to 3. 2 times 3, 6 times pi. The area is 6 pi for this ellipse. Okay, what about a pizza slice? So a part of a circle. Let's say we have theta again. So just think of it as a fraction of a circle, where we know that these two are the radius. So it's going to be theta over 360. Then we're going to times it by the area of the circle, which is pi r squared, and that's our area for the pizza slice. Let's say the radius is 2, and let's say the angle is 45. So this will become a quarter. So this will become 1/4 times pi times 2 squared. 2 squared is 4. The quarter and the 4 cancel out, so we're left with the area equaling pi. So that's it for this video. If you have any questions, feel free to Okay, so here I have a hexagon. Let's assume that all the sides are equal and all the angles are equal. This is a regular hexagon. How would I work out the area of this? So there's two ways that I could do it. I could realize that if I go from the corner to corner, I have two trapeziums. So all I had to do is work out what this is and what this is, and then I could easily realize that this is two trapeziums just stitched together. So all I'd have to work out is the area of one of them and then just double. Or I could say that, hold on, these are just a series of triangles. But these are equilateral triangles, so they all got 3 degrees. So they all have 60 degrees and they all have the same length. And then I can use Heron's and then times that by 6, and that'll give me the hexagon as well. So if you have a shape like this, see if you can turn it into smaller shapes that you can work, so you can work out what this shape's area is. So that's all the time that I have for today. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.